Okay, this you can say is equivalent to the action. This is equivalent to the action psi h minus I d by dt. Psi. Alright? Okay. So now this is the equation. From this you can also get, if I want to write, since I have d rho dt is equal to minus divergence of rho grad of phi, I take the second derivative, I'm going to get d2 rho by dt square equals minus divergence of rho grad of d phi by dt. Well, I mean, this right here. Okay, so I've got an equation for rho in terms of this, and then d phi by dt I can write in terms of again rho. So I've got an equation for rho.
How did you get the action that you have written there?
Well, I mean, I'm trying. What is this whole thing? It is like the expectation value of Hamiltonian minus d by dt, I d by dt. So I'm saying this is equivalent to that. So there is no other term.
Where is how do you say that del del d is coming? Where is this
Del del d, because there is no role of this term in stationary state theory. This came only when there is a time dependence. Velocity came only when there is a time dependence. Alright? So it came from there. If you just want to check, we want to be more rigorous, which I am not doing right now. This is Meldum's work of fluid equivalence. And for that, you write psi equals some r e raised to I st. Where s is a function of r and t. Then also you get it. Right now I'm not doing that. Okay, there is a fluid equivalence completely where ds by dt gives you the velocity, alright? Which you can actually check. If you write psi in this polar form, ds by dt, if s is r dependent, then
S is the action.
s is the phase, yeah. Whatever you want to call it. Okay? So that's what it is. Yeah, action also. So you can see it's finally related to d psi by dt somewhere. Okay, so now I'm going to use this in the context of Thomas quantum theory and show you plasma oscillations. How this automatically leads to plasma oscillations. Let us take homogeneous electron gas. Density equals rho 0, which is a constant, and ground state density constant. Apply perturbation E external 1 RT. I'll expand this in terms of first order. Then I'll assume that rho RT can be written as rho 0 plus some rho 1 RT. Alright, then I'll do the first order. In this equation, the first order equation will be d2 rho 1 dt square. Alright? And inside I'm going to get equals minus divergence of, since this is going to be rho 0 plus rho 1, right? D by dt. Rho 0 plus rho 1. Only when you apply time dependent potential that you get phi. So phi is the first one. Okay? Because if there is no time dependence, phi is 0. Phi was introduced precisely for doing so. Phi 0 is 0. Let me write on the side. Phi 0. Now, keeping only the first order terms, you're going to have this rho, this is first order, rho 1 and this term doesn't contribute, right? So only term you're going to have is minus d by dt, divergence of rho 0, grad of phi 1. Which now I can take d by dt inside, and I can write this as minus divergence of rho 0 grad of d phi 1 dt. Okay, so far? Now what we're going to do is write the equation for d phi 1 dt. What was the equation for d phi 1 dt? I just erased it. So I have d2 rho of dt square is equal to minus divergence of, right? Rho 0 can be taken out because it's a constant. And d phi 1 by dt was minus d by d rho and what's it? Plus. That's what I wrote, right? Okay. So this is fine so far, which I can write as minus rho 0 divergence of minus minus will be plus dE by d rho is going to be less now to Thomas forming, right? Delta T by delta rho at rho 0 plus integration delta 2 T by delta rho r prime rho 1 r prime dr prime. In Thomas formula there are only two terms, kinetic energy external, so external is going to be plus V1 external, right, plus V0 external, which was 0 anyway in the TG, right, plus the potential due to all this, which is going to be rho 1 r prime over r minus r prime dr prime.
So I think you have changed the index of rho 1 in the second term.
Rho 1 r prime, right?
It should be down there.
This will be the change. I'm calculating a rho 0 plus rho 1.
Right.
So add rho 0 plus the derivative times rho 1.
Rho 1 should be down there because we are
Now then I'm calculating it at this.
I'm talking about the index, the notation.
Oh, you mean this at all?
The index, right.
ठीक है. Okay. Alright, so here also. Alright, now this term is some mu at rho 0, dt by d rho in Thomas formula is mu for homogeneous gas. So grad of mu is the divergence of mu is going to be 0, and there is some wait a minute. There is some divergence also somewhere. There was a divergence of this, right? grad also. So grad of mu. And this is going to be grad of this. And this is going to be grad of this. This is going to be grad of this. Alright? So the grad also. This del dot rho grad of d phi by dt. Now I'm going to make certain approximations. Rho 1 is very small. And if you look at the second derivative of Thomas Fermi functional, right? P is proportional to rho raised to